All right, muchachos, let's talk about orbital velocity. Now, planet Earth orbit looks a little something like this. Let's pretend this is our sun. Our orbit, let's see, Earth is right here. Our orbit looks like this. All right, it's fairly circular. All right, this is a very bad representation of it. It's fairly circular, but it's also elliptical. All right, and an ellipse circuit orbit means that it's not completely circular. A completely circular means that this is one focal point, but here we have actually two focal points. All right, and if you don't know what that means, that's okay. It just means that this is an ellipse and this is a circle. All right. So Earth is in a elliptical orbit around the sun. And in fact, all things that orbit are in an elliptical orbit. The reason being is, as you move closer to a body that has a large amount of mass, so therefore a large amount of attraction, gravitational attraction, force of gravity, it has a large force of gravity, you're going to start going faster. You're going to start going faster, 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 boom. Back out again, and then we go faster, 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 boom. Back out again. That's sort of the motion of the planet. It's faster over here, and it's slower over here. It's faster nearest the gravity. It's slowest furthest from the gravity. Hope that makes sense. So how do we calculate the velocity of us orbiting? Well, we're going to have an average velocity, all right? We're not going to worry about calculating the velocity here versus here. You're going to have to do a lot of complex math, use Kepler's laws, and this is not the class to do that. If you take astrophysics in college, you will do that, and it's a very fun course, and I highly recommend it to anybody that's interested. So how do we solve these? Well, first step you want to do is know that there are two different forces acting on our Earth right here. Two different forces. There is the force of gravity, pulling it in, and the centripetal force. All right? And it turns out that you can set these two equal to each other. Our force of, let me write gravity first. Our force of gravity, which we know is G, M1, M2, over D squared. All right? And our centripetal force, which if you remember, Fc equals MAC, all right? Fc equals Mac. But if we want to bring that AC down a little bit, we should know that Fc is actually equal to mv squared over r. Now, r is the radius of which you're orbiting. And for f of g, your d is the distance you are from the center of gravity. So both represent radiuses. So these are actually going to become the same value. But let's see that happen. So we know that we can set these two equal together. We know that we can set force of centripetal force equal to the force of gravity on an object. And this is all so we can find the velocity of our object. So mv squared is equal, or mv squared over r is equal to gm1 over m2 over d squared. Now, like I said before, the distance from the center of gravity to the object is actually the same as r. So we're going to actually change this into r. Now remember, an r, when we're talking about centripetal force, is the radius of which we're going around. And the radius of which we're going around is equal to the distance from the center of gravity to the object. I can't emphasize that enough. We're simply just changing this into r squared, and it is the exact same. Okay, now we have a mass here, a mass here, and a mass here. Let's say that mass 2 is actually the mass of, in this case, Earth orbiting the sun. We're actually looking at the centripetal force of Earth, so we know that this is the mass of the Earth, so we can actually cancel these two masses out. And then down here, we see an r in the denominator, another r in the denominator, so we're going to actually cancel that out. And so we're left with v squared equals g m1, or the mass of the sun, over r. And let's actually bring that down one more, the square root of g m1 over r. So this is going to be the velocity of your orbital, or the velocity of your orbit, or your orbital velocity. The velocity is equal to the square root of the universal gravitational constant g multiplied by the mass of the object you're orbiting divided by the distance to the center of gravity. So let's write that out. V is equal to orbital velocity. G is equal to gravitational constant. M1, or we can really just leave it as M, is equal to mass of object we are orbiting. And lastly, our R is equal to the distance to the center of gravity. All right, so V is equal to the square root of G M1 over R, or Gm over R. So what is the orbital velocity of the International Space Station? Well, we know that the International Space Station is orbiting at 400 kilometers above the Earth's surface. 400 kilometers. And we know that centripetal force is equal to the force of gravity. So let's figure out all of the variables that we need. We need G. We need M. We need R. And we need V. And V is actually the one that we're looking for. So we know our equation from since the back of the sheet. We say, okay, we know that V squared is equal to G M. And from now on, I'm going to write this M as a capital M. All right, this capital M just represents the mass of the object we're orbiting. International Space Station is orbiting Earth, so this would represent the mass of the Earth at this moment. So that's our equation that we're looking for. We know G, 6.67 times 10 to the negative 11th. We know the mass of the Earth, 5.98 times 10 to the 24 kilograms. We know the distance from the Earth to the satellite. We know the distance from the Earth to the satellite is actually going to be the radius of the Earth plus how far away this International Space Station is in space. So I'm going to write that over here. I'm going to say E is going to represent the radius of the Earth, and I is going to represent how far away the space station is from the surface of the Earth. We can add these two together, and we'll get R. R is equal to E plus I. So let's find E. So we know the radius of our Earth is 6.37 times 10 to the 6th meters. And the radius of which our space station orbits above the Earth is 400 kilometers, but we need to change that into meters. So this is actually 400,000 meters. We can see that right here. 400 times 1,000. 400,000. All right. Now if we change this into scientific notation, that is 4 times 10 to the 5th meters. So let's see this. Our R is equal to E plus I. So our R is equal to 6.37 times 10 to the 6th plus 4 times 10 to the 5th. And this is going to give us an answer of 6.77 times 10 to the 6th meters. And let's see that right now. 6.37 times 10 to the 6th plus 4 times 10 to the 5th. And we get 6.77 times 10 to the 6th. Okay, 6.77 million meters. So now we can plug that in right here. 6.77 times 10 to the 6th. Oops. I should have actually wrote that out. And now we just plug everything in. V is equal to the square root 6.67 times 10 to the negative 11. Multiply this by the mass of which we're orbiting. 5.98 times 10 to the 24. And then we just divide this whole number by 6.77 times 10 to the 6th. See what we get. Now, this is called a graphing calculator. If you don't have this at home, that's fine. I'll show you how to do it the other way. So, in the graphing calculator, what I do is I press second, and I press this button right here, the x squared button. That gives me my square root. And then to get a nice looking division sign, I'll press the alpha button, I'll press F1, and I'll press enter. This gives me a numerator over denominator function. So I'll go ahead and press 6.67 e to the negative 11. Multiply this by 5.98 e to the 24. And then we're going to divide all of this by the total distance from Earth's center of mass, Earth's center of gravity. All right, and that gives me an answer, a velocity that is equal to 6,775.7 meters per second. Now, if you want to do this in one of these calculators, I'll show you how to do that right now. All right, so I'm going to press 6.67 e negative 11. I'm going to hit enter. I'm going to multiply that by 5.98 e 24. I'm going to hit enter. I'm going to hit enter one more time just to make sure everything's okay. I'm going to divide that by, press divide, I'm going to say 6.77 EE 6. I'll hit enter, and then when this comes up, I'll press square root, and that gives me the exact same answer. So that's how you do it on one of these calculators. All right, you should be able to do the rest of this worksheet on your own. Good luck. Rewatch the video if you have any questions.